Okay, in this problem, we're looking at an application of the law of cosines. And so, to paraphrase the problem, we have this structure here that is on the side of a hill, okay? And it is not making a perpendicular, it's not, it wouldn't make sense to go ahead and build the structure like that. And so, therefore, it's straight up and down, and we need to know the length of the wires that are going to be supporting this thing so it doesn't topple over since it's built on the side of a hill, okay? So what we're looking at is trying to go ahead and fill in as much about the two triangles as possible, but one of the pitfalls that we're looking at, since we're trying to find these guys right here, is we have no angular measure except for it's built on this hill that is at a 6-degree incline. So that said, let's take a look at an old school diagram here on the right to see how we can use that to help us reveal some angles. Okay, so if we have two parallel lines, okay, and they are cut by a transversal, if you remember this from the Math 2 days, is that you're going to get alternate interior angles. That said, in alternate interior angles, I also should mention that they are going to be congruent or equal to one another. So if I look at this right here, I'm just going to draw some parallel lines. So here would be one line right here, and here's going to be another line that is going to be parallel to it, okay, the best that I can. They're a little bit crooked, but here is the point that I'm trying to make. Actually, I'm going to move this up a little tiny bit here, and so I got some room to draw. There we go. And so that said, is that since this is a 6-degree incline, this angle right here is going to be 6 degrees. So that means is that this little bitty angle right there is going to be 6 degrees as well. Much like with the parallel lines cut by a transversal, the transversal here is actually the ground going through, like so. And so therefore, I know that that little angle is 6 degrees. So that means is that if this is going to be a 90-degree angle, because you wanted it to go straight up and down, right? So it's not, again, whatever, the structure is not leaning. So you would have 90 degrees plus 6 degrees, which is going to give us 96 degrees for that angle right there. So in turn, if I'm looking for this angle, I would have, since this is going to be 6 degrees right here as well, because we would have this business of vertical angles right here. Well, basically, let me highlight these a little bit. Right here and right here, those would be the same. And so since that would be 6 degrees, this is going to be 84 because I'd have to subtract that out. And so when I add them up, I know I'm going to get 180 degrees, which is the entire line. They're supplementary to one another, so I know that geometrically I'm good. So I'm going to clear out this picture a little bit so we can start to fill in some more information about the triangles and get to work with the law of cosines. Okay, with the angle measures all taken care of, we can progress on over to some of the sides that we need, and it looks like we're given this one, which is going to be 75, and the height of the tower, which is 100. Okay, so it looks like we are ready to roll. So I'm going to draw these triangles off to the right here and then solve them both separately. Okay, so there is kind of my crude rendition of these triangles, okay? And so we have first length, I'm just going to call X, and the second length, I'm going to call Y, and then feed these right into the law of cosines and see if I can get those to go ahead and, reveal themselves. Okay, so here are the two triangle setups, okay? And so let's work on the right-hand side of both those equations real quick. Okay, so there is the right-hand side, and all I did was put it in the calculator, and it did its heavy lifting for me. And so let's go ahead and take the square root of each side, and that is going to give us, okay, so there's our approximates for the guy wires, okay? And it looks like it makes sense because The one on the left-hand side is going to be longer than the one on the right-hand side, and so it does pass the first look test and seems legit. So that's going to be it as far as the ending lesson here in this video series. I do plan to release a video in regards to the proving the law of cosines in the next couple days. So go ahead and take a look for that. So, all right, I will see you in the next video.